Remember yesterday when we mirrored and flipped our triangles all the way around the axis? We were finding that as we did that, when we took this triangle and we flipped it around and moved it over, oops, I should have moved it. When we take this ordered pair here, it's a positive x and a positive y. Agreed? When we flipped it to the second quadrant, it became negative x and positive y. When we took it and flipped it into the third quadrant, it became what? Negative x and negative y. And then when we flipped it over to the other way, what did it become? Good. Over here it became positive x and negative y. Okay. Those ordered pair values don't change. What changes are the signs, S-I-G-N, positives and negatives. So what I want you guys to start to think about here is as we start to build in our first quadrant of the unit circle, this is all stemming from your specials. If I'm looking at first quadrant, excuse me, we're looking into the first quadrant here. I know that 90 degrees in radians is what? Pi over 2. And then 45 degrees was half of that. It was pi over 4. Now, a lot of times students have a tendency to make a mistake with which one goes with the 60, which one goes with the 30. 60 goes into 360 how many times?
6.
So that's pi over 6. No. I'm thinking 360. It's so then we have our, it's, which one was which? It's 1 over 80. This has not been a fun day. I was thinking full circle. Like I said, this has been a fun day. Dropping my keys is the least of my worries after today.
Wait, did you really just drop your keys? Yeah, you did.
So here's what happens. Each one of these ordered pairs as you go through, we discussed in the past that remember we listed out sine was y over r, cosine was x over r, tangent was y over x, and so on. That was telling us that we were looking at the coordinates. Remember we're doing the trig functions of any angle. So as I'm going through and I'm starting to build my ordered pairs, what I want you to think of is when you're at a 30-degree angle and you want to find its cosine. Remember, the cosine is its x value. When you're at a special right triangle, your cosine is your adjacent over your hypotenuse, root 3 over 2. Your x value is root 3 over 2. When you're at your 30-degree angle, your sine is your opposite over hypotenuse. In your special right triangle, again, your opposite is 1, your hypotenuse is 2. Therefore, the sine of it is 1/2. If I stay in the 30, 60, 90 and just go back to the 60-degree angle, what changes? It just reversed. You're switching your, instead of being your opposite over adjacent here, your opposite is now a 1. So your cosine of 60 is 1/2. The sine is the root 3 over 2. Okay. When I go to my 45, and this is also off of your chart, when you go to your 45, your cosine, 1 over root 2. We don't like that. We write it as?
Root 2 over 2.
Good. Is it the sine the same value? It's the same value because it's an equilateral triangle. So right now we know that we have cosine and sine for all of these values. The quadrantals we'll fill in later on. The quadrantals are the easiest of our worries, or the least of our worries, I should say. What this is going to allow us to do, guys, is that we're going to be able to take this first quadrant now, and we're going to be able to find every single trig function for any angle that works. For example, let's say I want to look at and find the sine of 7 pi over 4. If I want to find the sine of 7 pi over 4, I first have to identify what quadrant it's going to lie in. Which means we're going to draw and find its reference angle. Yes, sir? What quadrant? I don't know, I haven't done it yet. Do we agree that it's more than halfway? It's more than pi, right?
Yeah.
Right? As we draw it through, there's 1 pi, and this is 3/4 pi, correct? So what quadrant is that in? Fourth quadrant. When I'm in the fourth quadrant, I have to figure out how far off I am from the x-axis. How much more pi do I need to get to the pi over 4? So what's my reference angle? Pi over 4. My reference angle here is pi over 4, which means at this point, it is going to have the exact same ordered pairs as pi over 4 does here, except for one change. Y is negative. Fourth quadrant, your y values are negative, which means fourth quadrant here in terms of trig, sine is negative. The sine of pi over 4 from first quadrant is our y value, √2 over 2. What is the sine then of 7 pi over 4? Oops. Notice, we are not using calculators. You'll have to do this without a calculator. And everything is built off of the understanding of first quadrant right triangle. Right? I don't know. Let me group this up here. Let's look at another one. Again, I'm first quadrant. Sorry, we can't do that. Cosine of negative 3 pi over 4. I'm going to get the cosine of negative 3 pi over 4, which means the first thing I'm going to do is draw it and find the reference angle. When I draw negative 3 pi over 4, do we all agree that it's more than halfway?
Yeah.
So it's what quadrant? Third quadrant. Your ordered pairs in the third quadrant are what?
-3 and 4.
I'm just-
4, sorry.
Yeah, they're both negative. Cosine's negative, sine's negative, your x value is negative, your y value is negative. Everybody agree on that? Okay. Now, what's the reference angle here?
On pi over 4 is negative.
It's just pi over 4. Again, like what happens whenever you're talking about reference angles, your reference angle is always going to be a positive acute angle. How far away is it? It's pi over 4. Now again, this angle is going to mirror all the same characteristics of pi over 4 in the first quadrant. Because as you moved this over to here, and then over to here, the only thing that changed was its sine values, or excuse me, I want to say the positive or negative values. So if I'm looking for the cosine of negative 3 pi over 4, what is it? It's negative √2 over 2.
Maybe it's my growth plates.
Again, everything is mirrored off of first quadrant. You have to understand how the first quadrant is developed and put into place. Once you're able to work with this, everything falls into place. Come on, guys. All right. Cosecant 225. Cosecant is the inverse of what? Sine. Cosecant is the inverse of sine. So what's going to happen here is, first of all, again, draw it out. What quadrant do we wind up in?
Third.
We're in the third quadrant. What's its reference angle?
High.
When we're dealing with degrees, you can give me degrees. When it's in degrees, you stay degrees. If it's in radians, you stay radians. 45. Yes, sir. What's that? Now, again, that means it's mirroring what our 45-degree angle did here. And I'm looking for the cosecant. The cosecant is the inverse of sine. If sine in the third quadrant would be negative root 2 over 2, the cosecant then would have to be its inverse. Negative root 2. You have to remember to change the sign SIGN for that. Yeah.
So any of these angles are on the second, third, and fourth quadrant, they're all going to be negative?
No. Are your ordered pairs always negative in the second, third, and fourth quadrant? Are all ordered pairs positive or negative for second, third, and fourth quadrant? For what? No. Again.
Hey, Mr. Murphy, how do you get root 2 over 2? What does that mean?
It's the sine of 45. 1 over root 2. Rationalize. Root 2 over 2.
And then it just transfers to each coordinate?
Yep.
Right.
Ladies and gentlemen, you really need to stop talking. It's enough. When you're in the first quadrant, what are both ordered pairs? Or what are your ordered pairs both? Positive. 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 When you're in the second quadrant, what becomes negative?
X.
In terms of trig, it means it's a negative cosine. Third quadrant, both of them are negative. It stems from the exact same idea of ordered pairs. When you're working with trig functions, sines and cosines, remember, the cosine value is your x, your sine value is your y. This is when we did that, find the trig functions of any ordered pair. This is where all is stemming from. Yeah, Daisy.
So I get this part. And then the last one we have the inverse of sine.
Correct.
So sine to the third one is both are negative, so the inverse of both would be positive.
No, this SIGN, the positive negative of that, it stays the same.
Okay.
Okay? This is where a lot of people think that. In first quadrant, sine and cosine are positive. What's tangent? So
Tangent
if
is positive.
tangent would have to also be positive. Okay? If sine is positive, its inverse is positive. If cosine is positive, its inverse is positive. If tangent is positive, its inverse is positive. Yes, sir.
Positive.
The inverse of sine? No, the inverse of sine is still the y value, but you have to flip the fraction. So it'd be r over y. Okay. Over here, which trig function is negative? Cosine. Cosine is negative, sine is positive, which means tangent is negative. What's that? Talk louder, I can't hear you. Do you remember from 2 days ago when we said sine was y over r, cosine was x over r, tangent was? So what is tangent? Positive or negative divided by positive is? Negative. Yes, sir.
So tangent's only positive in the first quadrant.
Cosine's negative. Sine is negative. What's a negative divided by a negative? Positive. Which means all of their inverses mirror the same positive or negative sign, S-I-G-N. Willis,
Actually, I think my question is kind of stupid.
don't worry about it.
So would sine go with y as cosine goes with x? As far as the goes? Yeah, see, this is why I didn't want to.
It's what I've been saying for about a week now.
Right.
Did you write that down at any point in time?
Yeah, I did actually.
Okay. Are you ready in any of this now?
I've already written. Yes, Matt.
Get it?
So, when you do the inverse, the sign stays the same, but the numbers will.
Yes.
Okay.
The positive negative stays the same. The numbers flip. Okay. And then lastly, cosine is positive. Sine is negative. Therefore, tangent will be negative. Okay? That's how that works. It mirrors itself through, and you have to understand where all of that came from. Sine is y over r, cosine is x over r, tangent is y over x. The inverse functions mirror everything that like that. All right? Cosine of 240. If I want to do the cosine of 240 degrees, I need to first of all grab my where's 240 go? Third quadrant, very good. Come around past 180. 240 is how many degrees past 180? 60. Therefore, what is its reference angle? 60. Very good. Now, that means 240 degrees is going to have the exact same ordered pair as 60 degrees. If I'm up here at 60 degrees, my ordered pair, my cosine of 60 was 1 over 2. I'm sorry, yeah, adjacent over hypotenuse. It's 1/2. My sine value is root 3 over 2, just going back to the right triangle. Which means this value here comes down here, but what changes?
Both are negative.
They're both negative. Now, if I'm looking at the cosine, which value am I looking at? Yeah, the negative 1/2, the x value, very good. So the cosine of 240 degrees mirrored out of the 60, brought it to the third quadrant, creating the x value to become negative, you get negative 1/2. Again, the whole idea of this is that you'll have to be able to do this without a calculator. You're going to have to know how to set that up. Yeah?
Now, all these numbers,
Yes, you're never going to get, yes, you're not going to get anything on the unit circle that you can't do out of first quadrant. Later on in this, I don't know if it'll be this chapter, it might be next chapter, there is a way to find the sine of, a really easy one, pi over 12. It's half of pi over 6. It'd be a 15-degree angle. There is a method to do that, but it's not just taking half of 1/2. It's not going to be a quarter. There's a weird formula that lies within it that you have to use both sines and cosines to be able to develop it. It's just a multi-step problem. We will do that, but not yet. Okay? You will never have to do a unit circle problem that is not going to be, I'm not going to ask you to find the sine of 50. Then you have to use a calculator. Okay? Things like that, you have to use a calculator. Everything that we do like this is always going to be based off of right triangle trig, off these specials, off your specials, or your quadrantal, your 90s and things like that. Yeah, Kate?
what if it was, like, what if that 240 was, like, over 360?
If it was over 360, you just go around like you would and find a reference angle. You still do the exact same method. Let's see, I think I had an example. I'll give you 1 second, Shay. Thought I had one. Well, look at a, let's see, let's say it's the cosecant, excuse me, of 17 pi over 6. If I want to do 17 pi over 6, that's more than one revolution. You agree? 6 goes into 17 how many times? Twice. And then how much is left? 2 and 5 pi over 6. So I'm still going to graph this like I would normally. One revolution. 5 pi over 6 is going to get me to the second quadrant. Does everybody agree? What's my reference angle? Pi over 6. So this is going to have the same relationship as pi over 6 does in the first quadrant, only with the negative x, so it's negative. Very good. So over here, the negative would be on the cosine, and it's a positive sign. Cosecant is the inverse of which one? Sine. So it's just going to be the same exact sine value. No. Oh, yeah. Sorry. I think you were flipping this as far as the sine is. No. SIG. Yes. At this point, I think we should just call it sin and call it make just call it a day.
Sin. Yeah.
It should be, because the reference angles when we're dealing with the right triangle, if we're dealing with the special right triangles, it should be. Okay? It should be. It's kind of a giveaway. Yeah.
So like on a test, you would just give us the cosecant of that, and
Yeah.
then we have to find cosine inside.
In this one, I'll just ask you to find the cosecant of it. And then in this case here, that means I go back to what I know of my first quadrant. Pi over 6 is 30 degrees. Cosecant is the inverse of the sine value. So I'm going to find the sine of 30. Now, in my head, I can always go back and redraw this rather quickly.
Okay,
The
so
sine
you
value.
use those side lengths?
What's that?
You're always going to use those side lengths?
Yeah,
Oh, this.
because this is the ratio. It's always going to maintain that exact ratio.
Okay.
30, the sine of 30 is 1/2. So if I know that the sine of pi over 6 is 1/2, when I bring that into the second quadrant, that sine value is still positive, but the cosecant is the inverse of this. So what do I do to the 1/2? So what's exactly? And there you're done.
So, okay, I'm fine with cosecant, but I gotta find the sine.
Yep.
Okay.
You always start with the parent. I want to say the parent function, the parent trig function. Move that around, and then at the very end, flip it.
Okay.
Okay? Yes, Gunn.
Do you have a test tomorrow or Friday?
No. Who keeps telling you guys that there's a test?
Lance Sauter.
Yeah, he did. He came in, he was all freaking out. Is there a test tomorrow? Yes. Yes, there is.
What's it
That's actually
Okay. I'm joking. There's not a test.
The test over 15
No, it's over chapter 15.
Yes, exactly. Let's try another one.
Oh no, actually, yesterday it was the day after yesterday. It was like this.
Let's try a cotangent. We haven't done one of these yet. Boo. Cotangent. The cotangent is the inverse of what trig function? Tangent. So in the back of my mind, I know that cotangent is going to equal x over y. Because tangent is y over x. Everybody okay with that? So if I go through my ordered pairs, first thing I'm going to do is find my reference angle for negative 3 pi over 4. What quadrant does that put us into? Third quadrant. And have you figured out the pattern? I think Shay did. What is the reference angle going to be? Excellent. Your reference angle is going to be pi over 4. Now, at pi over 4, what were the ordered pairs? Remember, it's the 45, 45, 90. They're both root 2 over 2, aren't they? So if they're both root 2 over 2, that means they're both going to be root 2 over here, but they're negative. Okay? Now, When I'm dealing with cotangent and tangent, I'm taking, well, tangent I take y divided by x. What's negative root 2 over 2 divided by negative root 2 over 2? 1. So what's the inverse of that?
1.
What is the cotangent of negative 3 pi over 4?
1.
There you go.
I wish we could just stop. I think it's for a second.
Yeah, that's it.
Oh, yeah, we did.
Eh?
Yeah.
There is no dumb questions because Willis already covered that. Sorry, Willis. I'm sorry. It was too easy.
Tangent is opposite over adjacent. Y on the 45, 90 is not 1 over 1 because
And you picked up on a shortcut. If you're talking about the tangent of a 45-degree angle, it is 1 over 1. It is 1. What we were doing earlier is that we were taking it via the ordered pairs. The cosine of 45 was root 2 over 2. The sine of 45 was root 2 over 2. We were just basing it off of this. It's one way of doing it. If you recognize this, and Shane brought up a great idea here, guys. Whenever you're dealing with tangent and cotangent, once you relay it back to a special right triangle, 30, 60, 90, 45, 45, 90, and you can find the tangent of 30 degrees being 1 over root 3 over 3, there's your tangent. You don't have to go through the whole rigmarole of dividing out your ordered pairs with all those fractions if you don't want it. Tangent and cotangent kind of help you. It's kind of a little cheat sheet for that. It works. Not a problem with that.
So you're not allowed to say no.
Yeah, if you want. I'm not going to say no. I'm not going to say no. Sines and cosines, you're going to find it's going to be a lot easier to mirror with your ordered pairs. Tangent, cotangent, it's okay. All right, I think we got time for one more. Tangent, 5 pi over 6. Tangent, 5 pi over 6. Second quadrant, very good. What's your pi over 6? Which means over here it's pi over 6. Pi over 6 is which degree?
30.
30. So if I go to the Shea method and I want to do the tangent of 30, 1 over root 3, which is? It's a nice trick to do it that way for tangents. What's that? What is the measure of that angle? Now, it's in the second quadrant though, so what does it have to become?
Negative.
Now, Shay, be careful when you use that method not to forget what the SIGN, the positive or negative sign, is going to be.
Okay.
All right.
So do we even
Sign, SIGN, like this positives and negatives.
Mr. Murphy?
Yes, sir.
I guess I'm still confused on how to get the coordinates.
Everything is built. Everything we do, Willis, is built off of your special right triangles. What I want you guys to do tonight is on the next page, it's 789. I want you to do these by hand, but my suggestion to do this on your paper, draw your first quadrant. Draw your first quadrant, guys. Label your ordered pairs. And every time you find a reference angle, it's going to be mirrored off of that first quadrant. There's not going to be anything on here that won't get you a reference angle out of the first quadrant.
45 through
These
60?
will all be either a 30 degree, 60 degree, or 45 degree.
Yes. And Daisy was asking about that earlier. I cannot give you guys anything that you can't do yet.
So the reference angle.
Yeah, your reference angles are always going to work. It's going to be 30, it's going to be a 30, 45, and 60. It could be a quadrantal, a 90, 270,
Yeah.
there's 0. It could be one of those, but we did a lot of work on those, and you hopefully you guys found that those were the easiest ones.
Yeah.
Okay?
What's our one with
That.
that? 50.
Do you want us to know all of them?
Yes.
How about we do even?
Is 48 through 60 crossed out?
No, it just when I took this at.
So
Is it-
45 to 6.
Yep.
You like yell.
Oh, Mr. Murphy gave you 16 problems. He's such a jerk. I gave you more work to do last night. Count the problems with that table. There was 18 things you had to fill in right off the bat. Quit your whining.
But, Mr. Murray, can you go back to that first quadrant thing?
You don't have it written down yet?
I was in the middle of writing it down.
Do you have your table from last night?
Yeah.
Then you're fine.
Yo,
Okay.
smoke marijuana. I don't know.
Gentlemen, again,
Good, what's-
when you're working on these things, guys, this is really going to get very difficult real fast. You got to really keep up here. All of this stuff is based off the two special right triangles that I've been beating you over the head with. If you can draw the special right triangle, write out the ratios of the sides, everything falls into place off of that. Understanding that C comes before S in the alphabet helps you remember that X comes before Y. And everything goes. Okay? Use your ordered pairs like you would any other when you were plotting stuff in the past, whether what quadrant things are positive versus what quadrant things are negative, and everything goes off of it. Okay? You'll be fine.
Do you want us to draw the rest of these?
Sometimes it's helpful to get that way you can get your reference angle. And then once you do that, I mean, a lot of times, you know how I was just kind of rough sketching to figure out where it's going to go? I knew what it was, and then I would just go right to my first quadrant, and I would look off of that to figure out what to do. Okay? All right? Give that a shot, guys. You're going to be all right. You're going to find out that it's not as scary as it looks.